Hello, this is a continuation of Intro to Pandas Part 1. Where we last talked, we had illustrated how the append function returns a brand new data frame containing the result of the append operation. And if you don't receive that brand new data frame into some variable, then you will lose it. And I had created this simple scenario where I reproduced all of the code from a couple of previous cells in the notebook. I created two data frames, I appended them together, and then I stored that result returned by append into a brand new data frame. And then I printed that out. Let's see if it worked this time. There it is, that worked. The first print statement shows me what I started with, which was 4 rows. The second print statement shows me what I was trying to append, which is 2 rows. The third print statement shows me what append sent back to me, which is 6 rows. And that's the way it's supposed to work. The error, which we had already talked about, but I'll repeat here, is that we call df.append, but we don't catch or receive or store what comes back from append. When we run that, we still get the original 4 rows in df. And again, I'm just harping on this so that you don't make the same mistake and you don't think that append is broken or that you're using it incorrectly. And you kind of are using it incorrectly because you're expecting it to overwrite df with a new appended version when it's not really doing that. Something just to watch out for. Continuing onward, let's go back to our slides. We have another example of what I can do to a data frame. In this case, I've realized that what I have is great. I have 6 rows and I have 4 columns and I need to append another column. So I've added 2 data frames together. Now I'm adding a column to that new wonderful data frame. My source of data will be a dictionary, key value pair. The key is apples. The value is a list of 6 integers. And then I know that I can play a trick where the items method of the dictionary returns an iterator, which lets me step through the elements in the dictionary. And as I step through the elements, I add them to the data frame. But in this case, I don't have to do any fancy tricks about storing things. I just assign a new value to the key. So the key becomes the column name in the data frame, and the values are taken to be the individual rows in that column. And since there are 6 stores in the data frame, 6 rows, then this value better have 6 things in it. Then I print that out, and you can see over on the right of the printout at the bottom of the slide there that there's a new column called apples. And you can ignore apple, that's just the leftover from something else. I made a note on the slide if you'd like an exercise to do. This would make a good function. Write a function that accepts a dictionary and appends that to a data frame. Because we like to write modular code, and if we were in class right now, I would have you stop and write that little function for me just as an exercise. Let's go back to our notebook again. Here's the code. I can run it and I can see that it adds the apples column. Let me just flip back here just to clarify. There's a little extra column in the snip on the slide that really shouldn't be there. You can just ignore that. That just kind of popped up from some other work that I was doing. So just ignore that apple column. So once I've got all of this wonderful data, I can start to do some analysis on it. And here's a very powerful tool. Since I have this semantic indexing going on, I can simply reference the row index name, apples, and then I can do statistical analysis on that particular row. So the first line of output prints the maximum value for each column, and the second line of output prints only the maximum value for the apples column. So let's go back over, and there's our code print. There's our 6, which is the output of that last print statement in the cell. Let's break it and see what happens. We don't have a row called apples X. There is no index by that name. That means that's going to fail. Let's find out what happens. Data frame object has no attribute apples X, and we know that's true because we didn't create a column with that name. All right, get that out of there because that's just a mess. And I think I referred to that as an index a moment ago. I'm sorry, that's not an index, that's a column name, my mistake. Something else I might want to know is what stores are doing all this hard work. So I can create a Boolean column, and then I can use that Boolean column to map into the data frame as an index. And I did this last week, I believe, in a slide. I illustrated this technique, but it's just so amazing that I can replace many lines of code with one line of code by creating this Boolean. So let's go look at that. There it is right there. The first print statement shows you that Boolean. Okay, there it is doing all the hard work. Inside the print statement, it does two things. It computes the maximum value for apples. Okay, what store sold the most apples? What row has the highest value in the apples column? And then, after it's got that number, which is 6, it compares that to every other row in the series, in the column. If it's equal to 6, it generates a true value. If it's not equal to 6, which means it's going to be less than 6, it generates a false value. Okay, so there's your Boolean array right there. And that becomes a map. Then it uses the map in the second print statement to decide which rows to print. So once you've got the map, false means don't print that row, true means print that row. The only row it's going to print is Meyer because Meyer had the 6 in it for apples. And then there's the result of that print statement down there, which is really cool. And I suggest that you take some time to work with this and study the concept of creating this map and then applying the map to decide what to print. Remember, what I put into this index tells me what rows to print out of the data frame. So let's try it let's try a different perspective. Printf, prints, that's a different language. df, square bracket. What if I just put a 1 in there? And let's comment these out so we have less output to look at. Okay, it doesn't like a 1. Okay, because we don't have any index 1. Can I put apple in there? Can I put apples? So that just gives me the apples. Can I put apples, comma, and what are some other columns in there? Pears. Let's try that. Did I spell pears wrong? On the next slide, remember that what we did was we found out the maximum value in a column, and it printed out 6. Which isn't necessarily all that helpful. Okay. But, trying to get back to my slide here, we know that the next thing the customer is going to ask us is, what store was that? And they might not even care what the number was, they might just want to know the store. So we can take this wonderful syntax that we built here, and we can add on to it the index property and then index off of the index property to get the 0th column, which is going to be the store. And that's going to look like that. So we just get Meyer. All right, in keeping with our theme of data types, I added some more code just to print out the data types. So I printed out the data type of just the index. Okay. And that's going to tell me, if you look at the output here, that it is a thing called an index, pandas.core.indexes.base.index. Without going into any more detail, that's something you could look up and find out what to do with that, what properties and methods it has, how can you index into the index, and what sorting you can do on it and searching you could do on it, things like that. So that's another topic for discussion or topic for research. And then I added the type function to that second thing that we printed out, which remember was just the name of the store. Okay, that just prints out Meyer because Meyer sold the most apples. And that's no surprise to see the data type of that is a string because the index column consists of strings and one individual store is a string. So we just verified that that's what we thought it might be. And that prints out over here. There it is. And then if you see that that's a string, you can immediately begin to relate to it a little better and think about all the things you can do with a string. And again, I think it's just useful to have in the back of your mind some concept of the data types that you're dealing with. All right, something else we can do is sort. And sorting by rows is often useful. We do that in spreadsheets too. So I can call one function called sort_values, and I can sort all the rows. In this case, I sorted by the avocados row, and I only ask for the first 5. I mean, there are only 6, but just to illustrate the concept, I ask for the first 5. If I had a million rows, it'd be useful to ask for the first 5. And then I can see that the very first row has the most number of avocados sold, and then they show up in descending order. So Meyer's winning all the races here. They sold the most apples. They sold the most avocados. From observation, they sold the most pears too. So very busy store there. Whatever's going on there, they're selling a lot of fruits and vegetables. There's my sort. Of course, if you spell this wrong, are we case sensitive? Okay, do the column headings in a data frame appear to be case sensitive or not? Well, here's a simple test. It's a lowercase a in avocados in the data frame, but what if we call sort values and pass it an uppercase A? What do we get? There you go. We get a key error. I can look at that and say, oh no, I've got something wrong with a key because it says key error, and that doesn't tell me a whole lot. But if I look up at the line of code where it took place, hopefully I can realize that the key that I passed was avocados, and I simply spelled it wrong. So I can fix that. Another thing I can do is filter by column. This is what I just did where I illustrated avocados, so we won't go over that again. Just used watermelons instead of avocados. Filter by column. Here, instead of doing just show me something, I'm saying create me a brand new data frame. Okay? And I'm going to store that into a data frame called just pairs. This is an illustration again of making sure you understand that this method, which is actually the constructor of the data frame class, instead of doing something to DF, okay, it creates a brand new data frame and sends that back to you. And if you're not receiving that and putting that somewhere, you're going to lose it. You won't have access to it anymore. And that simply gives you a brand new data frame. It's got the indexes, they persist. The column heading for the indexes persists, but the only column in the data frame is just pairs because that's all you filtered on right here. All right, we can slice that way. And back in the code, we can demonstrate that it works. There it is. And the last thing we'll do in this slideshow is what everybody does the first time they learn about data frames is the amazing and wonderful describe method. Okay, I'm calling describe on the entire data frame and I get a whole bunch of statistical values for each of the columns. I'm calling the describe method on a particular column and I get just the statistics for that column. And then I'm drilling down to say, I only want the mean sales number for the guava column, and all I get then is just that number. And you can see how easy it is to drill down through the statistics. And that goes back over here, and we run that. Bada boom. And there it is. And that brings us to the end of this slideshow, I think. Yes, it does. Thank you for watching and have a great day.